Welcome to Mr. Tech. Today we explore the programming language revolution, the story of how humans taught machines to think in words, logic, and structure. This is not a random list copied from somewhere else. This is an original timeline of ideas that built software, the internet, smartphones, cloud computing, and artificial intelligence. Every major language was invented because the previous generation hit a wall: too slow to write, too unsafe, too hard to scale, or too far from the problem being solved. By the end of this video, you will understand why assembly still matters, why C became the foundation of modern systems, why Java conquered enterprise software, why JavaScript owns the web, why Python rules data and AI, why SQL still pays salaries, and why new languages like Rust and Go are rising right now. If you are a beginner, this will give you a map. If you already code, this will connect the dots. Let's begin the revolution. In the earliest days of computing, programmers spoke the machine's native language, binary. Ones and zeros. Flip a switch. Load a punch card. Make one mistake and the whole program collapses. Then came assembly, a human-readable map of those instructions. Instead of raw binary, you could write mnemonics like move, load, store, and jump. But you still managed registers, memory addresses, and exact processor behavior by hand. It was slow to write and easy to break, yet it unlocked unmatched speed and control. Even today, operating system bootloaders, device drivers, and ultra-performance routines still touch this world. The first revolution was simple but historic: stop writing pure binary, and start writing instructions humans could actually reason about. In 1957, Fortran changed everything. Short for formula translation, it lets scientists write mathematical formulas instead of wrestling with machine details. Weather models, physics simulations, aerospace calculations, and engineering problems suddenly became practical on computers. Fortran proved a critical idea that still powers modern software: a compiler can translate human-friendly code into efficient machine instructions. That idea is the root of almost every language that followed. Before Fortran, many people believed high-level languages would always be too slow. After Fortran, the industry learned that smart translation could be both readable and fast. The revolution had officially begun, and programming was no longer only for hardware specialists. While scientists got Fortran, business got COBOL, a language designed to read almost like English. That mattered because companies needed software for payroll, inventory, accounting, and government records. COBOL was never trendy in developer culture, but it became the backbone of financial and administrative systems around the world. Decades later, huge amounts of critical infrastructure still depend on it. This chapter of the revolution teaches an important lesson: the most popular language on social media is not always the language running the money. Reliability, readability for business teams, and long-term maintenance can matter more than fashion. Then came C in the early 1970s. C struck a rare balance: powerful enough for operating systems, clear enough for large projects, and portable enough to travel across machines. Unix was rewritten in C, and that decision echoed across decades of computing history. C gives you pointers, manual memory control, and a mental model of how computers actually work. From embedded devices to databases, language runtimes, and operating system kernels, C is still everywhere. If programming languages were a solar system, C would be the gravity well. Many later languages, including C++, parts of Java's ecosystem, and even major Python implementations, stand on C's shoulders. Learn C, and you understand what higher-level languages are hiding from you. C++ extended C with object-oriented programming, templates, and stronger abstraction tools without abandoning speed. That combination made it the backbone of game engines, real-time graphics, browsers, trading systems, and high-performance applications. The revolution here was architectural. Software could model the real world as interacting objects while still running close to hardware limits. C++ taught the industry that abstraction and performance are not enemies when the language is carefully designed. Yes, it can be complex. But that complexity exists because the problems it solves, frames per second, latency, memory layout, are ruthless. When milliseconds matter, C++ remains a giant. Java arrived with a bold promise: write once, run anywhere. Through the Java virtual machine, the same bytecode could travel across machines with far less rewriting. Banks, airlines, telecoms, governments, and huge backends adopted Java because it was stable, scalable, and backed by a massive ecosystem. Garbage collection reduced entire categories of memory bugs. Strict structure helped large teams collaborate on long-lived codebases. Java's revolution was not only syntax, it was trust. Businesses finally had a language culture built for mission-critical systems that must keep running for years. Even today, countless enterprise careers begin with Java, Spring, and JVM tooling. JavaScript started as a small scripting tool inside browsers. Critics dismissed it as toy language energy. Then the web exploded. Every interactive page needed JavaScript. Forms, animations, dynamic content, single-page apps, all roads led to JS. Later, Node.js moved JavaScript to servers. Today, JavaScript and TypeScript power websites, mobile apps, desktop tools, APIs, and developer tooling. The revolution was distribution. JavaScript won because it shipped with the browser, the most installed runtime on Earth. When a language is everywhere by default, developers follow, libraries multiply, and an ecosystem becomes unstoppable. Love it or hate it, JavaScript changed what software delivery looks like. HTML is often debated: is it a programming language? Strictly speaking, it is a markup language. But in the revolution story, ignoring it would be dishonest. HTML defines the structure of content on the web: headings, paragraphs, images, forms, and meaning. CSS styles that structure. JavaScript makes it interactive. Together, they created the most democratic publishing platform in history. If you want to understand modern software products, you must understand how information is framed for users. HTML is that frame. Every website you have ever opened is standing on this foundation. Python won by being kind to humans. Clear syntax. Readable code. A culture that values simplicity. First it conquered education and scripting. Then automation. Then data science. Then machine learning and artificial intelligence. Libraries and frameworks turned Python into a gateway for research and production systems alike. The revolution Python represents is accessibility. More people can turn ideas into working software faster than ever before. In the AI era, Python is often the first language of experimentation, training models, cleaning data, bluing APIs, and shipping prototypes. It is not always the fastest language at runtime, but it is frequently the fastest language for human progress. While other languages evolved for apps and systems, SQL evolved for truth, the data itself. Structured query language lets you ask questions of tables, filter rows, join relationships, group results, and aggregate numbers. Almost every serious product stores critical information in databases, and SQL remains the common tongue across tools and vendors. Frameworks come and go. ORMs hide complexity for a while. But when performance drops or business logic gets serious, teams return to SQL. In the programming revolution, SQL is the quiet constant behind dashboards, banks, analytics platforms, and recommendation engines. If you understand data, you understand power. Rust represents a new chapter in systems programming. It aims for C and C++ level performance, but with strong guardrails against memory bugs. Its ownership and borrowing model makes entire classes of crashes and vulnerabilities harder to ship. That is not marketing fluff, it changes how engineers design low-level software. Companies now use Rust for browsers, cloud infrastructure, embedded tools, command line utilities, and security-sensitive services. The revolution here is confidence. Write low-level software without accepting the old dangers as inevitable. Rust is stricter up front, and that strictness is exactly why many teams trust it for the future.
Go, often called Golang, was designed at Google for large engineering organizations that needed clarity and speed of delivery.
It favors simple syntax, fast compilation, and built-in concurrency with coroutines. In the cloud-native world, containers, microservices, APIs, and developer tooling, Go became a favorite.
Projects like Docker and Kubernetes helped carry its influence across the industry.
Go's revolution is operational. Languages should help teams ship reliable networked services quickly, not drown them in clever complexity. When your problem is distributed systems at scale, Go feels like a practical answer.
Now we enter the AI coding era. Assistants can generate functions, tests, refactors, and even whole modules in seconds.
That does not end programming languages, it raises the value of understanding them. If you know Python, JavaScript, SQL, and systems thinking, AI becomes a multiplier. If you know nothing, AI becomes a confusion machine that produces code you cannot debug. The next revolution is collaboration between human judgment and machine speed. Languages remain the interface between ideas and execution. Your clarity, architecture sense, and verification habits remain the advantage. The winners will not be people who avoid AI, or people who blindly trust AI, but people who can direct it. So what should you learn first? If you want websites and digital products, start with HTML, CSS, and JavaScript. If you want data, automation, and artificial intelligence, start with Python and SQL. If you want operating systems, engines, or deep performance work, study C and later explore Rust. Java remains excellent for large backend and enterprise careers. Go is outstanding for cloud services. There is no single winner for every human, only the right language for the problem you want to solve. The real revolution is choice. Pick a path, build projects, and let real software teach you faster than theory alone. From assembly to Fortran, from COBOL to C, from C++ to Java, from JavaScript to Python, from SQL to Rust and Go, every language was an answer to a limitation of its time. That is the programming language revolution. Tools will keep changing. New languages will appear. AI will write more code every year. But problem solving, clear thinking, and understanding trade-offs will forever stay human. If this original explainer helped you see the big picture, subscribe to Mr. Tech for more coding, AI, and computer science videos. Comment your first programming language below. Thanks for watching, now go build something.